This is 11.8 similarity transformations. In a dilation, the two figures are not congruent because they change size. We learned in 11.7 that a dilation either enlarges or reduces a figure. It keeps the shape, but it changes the size. Two figures are similar if the second can be obtained from the first by a sequence of transformations and dilations. So before we had that things were congruent, we had congruence transformations, and that meant you used either a rotation, a translation, or a reflection to get from one to the other, because those keep the same shape and the same size. But if now we're doing a dilation, we have a similar figure instead of a congruent figure because it's not the same size, it's just the same shape. So number 1 says determine if the two triangles are similar by using transformations and explain your reasoning. Well, let's look at the shape first. I see I have a blue triangle and a green triangle, and they look to be exactly the same shape, so that checks off. But they are different sizes. From the blue to the green, it gets way bigger, so there's some sort of dilation involved. Well, if I had this line right here as my line of reflection, I could reflect this triangle over that line, and it's going to become the same orientation as PQR. So I would say a reflection works, but then I would have to make it way bigger. So I would say, yes, a reflection and a dilation will produce that figure, but a dilation with a scale factor of what? So a dilation with a scale factor of, well, let's look at our scale factor. I see that this length is 5.8 and this one is 11.6. I'll count the other ones. I see this is 1, 2, 3, 4, 5. And this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1, 2, 3. And this is 1, 2, 3, 4, 5, 6. So to get to each of the corresponding parts, well, if I'm going from 5 to 10, I multiply it by 2. From 3 to 6, I'm multiplying by 2. And from 5.8 to 11.6, I'm multiplying by 2. So I could say the scale factor is 2. And that will map the first one, triangle STU, onto triangle PQR. Now the direction is important. If this is the figure I start with, I see that from pink to green it gets bigger. But if that was the one I ended with, it would get smaller. We also learned in 11.7 that if your scale factor is bigger than 1, your figure gets bigger. Well, in this case, my scale factor is 2, so it makes sense that this got bigger. Now, if I was going the opposite direction, if I was going from green to the pink, my figure would get smaller. So my scale factor, instead of being 2, would be 1/2. Determine if the two figures are similar by using transformations and explain your reasoning. Okay, well, it looks like they're both rectangles, and it looks like if I moved this green one down and over there, okay, I would get the same figure, or in the same position. I could also move this one over here and this one up here. Okay, so I could translate it some sort of way. So let's count and make sure that these things are actually similar. 1, 2, 3. I see it's a rectangle, so this is also going to be 3. 1, 2, 3, 4, 5. So this is 5. Come over here. I have 2 and 2. 1, 2, 3, 4. Okay, well, is there something I can multiply 3 by to get 2 and 5 by to get 4? Well, it's not going to be the same, we're going to need different numbers. So therefore, it's not similar. I can say no. The ratios of the side lengths are not equal for all of the sides. So scale factors, I'm looking for something to multiply. So if I'm working backwards trying to find the scale factor, I can do the ratio because the ratio means I have division. So if I say side AB, the side that goes with AB on the other figure corresponds with EF. So that gives me 3/2. If I look at AD, AD corresponds with EH. So again, in the previous example, we were looking for what multiplies. This one we're working backwards to see what divides. Well, 3/2 is not equal to 5/4. Therefore, even though I could translate, I could move it up and to the right from blue to green or down and to the left from green to blue. I can do that translation, but there is no dilation because remember we have to multiply both sets of sides by the same exact thing. You can also use the scale factor to find a missing dimension. The sides of a square are 32 inches long. So I'm going to draw out my square first. Special thing about a square is all the sides are the same. Put those congruent marks on, so all of the sides are 32 inches. It is related to a smaller square by a scale factor of 0.25. So we have a smaller square, and it's related by this scale factor. Remember we had the scale factor was k. How long are the sides of the smaller square? Well, if we know the scale factor and the sides of the original, I can multiply to get the new sides. Similar to what we did last section. Well, I don't need to do it 4 times because I know that it's going to be the same for all of them since it's a square. So I'll do 32 times 0.25, same as 32 divided by 4. That gives me 8 inches. So the length of the sides of the smaller square would be 8 inches. An art show offers different size prints of the same painting. The smallest print measures 24 centimeters by 30 centimeters. So let's start there. Smallest is 24 by 30. A printer enlarges, so it's getting bigger, by a scale factor of 1.5 first. It's going to get a little bit bigger. And then it enlarges the second image by a scale factor of 3. Got a little squiggly there. Okay. What are the dimensions of the largest prints? Are both of the enlarged prints similar to the original? Okay, so let's solve for these first. This one would give me 24 times 1.5 and 30 times 1.5. Well, multiplying by 1.5 is, sorry, I don't know why it keeps doing that again, is going to be the same as multiplying by 1. So 24 times 1 is 24, and then half of 24 is 12. So you add those two together, 24 plus 12, and you get 36 for here, here. Okay. And 30 times 1.5 is the same as 30 times 1, and then half of 30 is 15. Add them together, you get 45. So our second print is 36 by 45. Okay, now we have to enlarge it with a scale factor of 3. So I have to multiply each of those by 3. Switch colors here. 36 times 3 and 45 times 3. Well, 45 times 3 gives me 135, and 36 times 3 gives me 108. So, the new dimensions of the largest print would be 108 centimeters by 135 centimeters. Now the shape stayed the same. It was still a rectangle in every single case, but the size changed, first by 1.5 and second by 3. So are they all similar? I would say yes, because they're just dilating by different numbers. So at this point, you guys can stop. Your notes should be all filled in, so I would kind of go through, make sure you have all of your notes filled in because I am going to check those on Zoom. So flip through all of them all the way back to section 1, and then make sure you work on your chapter 11, section 8 assignment.